Okay, time for a little bit of kitchen chemistry. Further support this theory of substances being made of particles. So here I've got a glass of water. I'm going to use some squash, which for those of you not from the UK, it's a fruit flavouring you add to water. It's the one I've got is apple and blackcurrant. I need to hide the green-blue of my tiles, which is what the paper towel is for. So it's easier to see. And as you can see, as the squash is added in, the squash is moving in random directions. The reason for this is the particles of water, the billions upon billions upon billions upon billions of them, are all flowing. They're moving in random directions and they collide with the coloured squash, which is creating that swirling pattern. And you see the same effect if you see sunlight coming through a window and dust particles flowing in the air. That's caused by those dust particles being beaten by the gas particles. Now, a good theory should also provide you with a method of testing what are called hypotheses. A prediction, something you can test. So, if particles can flow, then if they can move faster, you will get different effects. And if we're looking at particles bumping into one another and causing things to spread out, then surely if particles move faster, things will spread out faster. So what I've got now is two glasses, one with hot water straight from a kettle and another with ice cold water that was chilled from the freezer. This time I'm going to use tea bags to show what's going on to make it a fairer experiment. I did try this with the squash, but I couldn't squeeze the exact amounts into each one and it was affecting the results. So, the hypothesis. In a hot substance, particles will have more energy. They move faster. And therefore, in the hot water, the particles of water will collide with the tea more often, more frequently. And that increased frequency will then cause the coloured tea particles to spread out faster compared with the cold one where it's going to be really slow. And as you can see with the hot one that came recently from the kettle, the tea is spreading out quite quick. And you're still getting that swirling motion because the particles are bumping in random directions. And it's the net effect of all of these particles bumping into each other that's causing that spread out randomly. Meanwhile, in the cold one, those particles are not moving fast enough to bump off the individual tea particles and cause them to spread out. In solids, because the particles can't move, they can only vibrate, it's impossible for other particles to spread out. So if I just dump these tea bags in solid ice, the tea is not going to spread out, not until the ice starts melting. And as you can see, the hot water, the particles are moving so quickly that tea, or those tea particles, have now spread out a lot. We say they are moving from a high concentration where there's a lot of them, in this case where there's those darker spots, to where there is a lower concentration, where it's a lighter colour. And eventually it will form one uniform colour that is lighter than those initial darkened spots. They are at a lower concentration. If you examine any one spot, there's going to be fewer particles than where you first saw the tea right when it began to spread out. And now I'm agitating the tea bag, just try and get some of those tea particles out, so you can see I'm not doing anything weird with what the substances are. It's just that water is so cold, the tea can barely make it out of there. And this is one you can try it yourself at home, just to observe the effect. Just make sure you're being careful with the hot water, particularly with glass, in case it shatters. Anyway, have a good day.